My presentation, of course, before all, I would like also to thank the organizers of this event and of the overall gear effort. My talk will be about geotechnical effects with emphasis on the behavior of the port facilities in Samos and Chios Island. That will be followed by observations on liquefaction and lateral spreading effects that will be presented by Professor Pelekis. Actually, it is the material from chapter 5 of GEAR report that was coordinated by Professors Klimis, Ziotopoulou, and Mylonakis, and contributed besides me and Professor Pelekis also by Professor Psaropoulos. Now, starting with Samos Port, there are 5 ports, actually. 3 of them are in the north part of the island and 2 of them are in the south. The most important ones are in Rovithis, which is the capital city, and Karlovasi. And there are 3 smaller ones that actually serve fishing and small yachts. And if someone would like very general and qualitatively to assess the performance of the quay walls, the picture is this. So the most affected ones were in the north part of the island, which is closer to the rupture zone, while the less affected ones are in the south part, as will be described in detail in the following slides. Now, starting with Rovithis Port, the old jetty, where the maximum values of settlements and rotations were recorded, one can observe that the Reconnaissance field revealed a rotation of about 4 to 5 degrees of the quay wall towards the sea, leading to a lateral displacement of about 35 centimeters, while the backfill settlements was quite considerable in some locations, measured up to 50 or even 60 centimeters. You can see here in the bottom right figure the same vertical dislocation from another view. Very fortunately, we have in our, there is available a borehole log that was provided to us by George Mylonakis, where exactly at the location of these large deformations, where it reveals that there is a 3-meter thick, a very loose sandy silt or silty sand at the depth of 15 meters that can be, of course, potentially liquefiable. However, we believe that the traces of sanded gravel ejecta that were also observed maybe are not due to this liquefaction due to the very high depth, and of course take into account the low amplitude of motion that could possibly trigger such liquefaction. Now, going to the new port, to the west side of Rovithis Port, we have a very good picture of the quay wall section around, along the sides A to B. It is constructed from a series of boulders restraining the backfill material of a total height of 8.75 meters that was made available to us by a project from Triton Consulting Engineers. That was under construction, some strengthening works during 2017, where also at that time it was discovered that there are minor failures, including open joints, subsidence of the backfill, and surface cracks. Therefore, we have strong support to believe that the earthquake actually intensified these pre-existing failures, inducing mild erosion of the massive quay walls and opening of existing gaps, as well as settlement of the backfill. However, we don't have in this case clear evidence of liquefaction, as at the time of the visit, it was not easy to identify material from ejecta because there are also materials from the construction works. However, another borehole reveals the existence of the very loose layer that I talked about earlier, but in this case it gets thicker and it appears in shallow depths, that should be related to the surface manifestation of soil liquefaction that will be discussed in the following presentation by Professor Pelekis. Now, going to the Karlovy Port, which is in the western part of the island, there are two jetties. In the east quay wall, a number of pavement longitudinal cracks were recovered, while the displacement of the quay wall sections were measured in the range of 16 to 45 centimeters in the lateral direction, while vertical dislocations were up to 50 centimeters in some cases. For the west quay wall, the picture is more mild. The lateral displacements are lower, while in this case there are clear evidence of sand and gravel ejecta that were observed in this quay wall. Although yet we don't have data on similar boreholes that could identify the materials of the backfill material, but we have, at least from a geological point of view, we can believe that the ports in Karlovy and Vathi are founded on the same geological structure, which is formed mainly from recent alluvial deposits. Now, going to the northern part of the island, in the Malathokambos port that was surveyed by Professor Pelekis beyond Gire port, the lateral displacements are lower, in the range of 3 to 6 centimeters, while for the other two older ports in Kokari and Pythagorio, again the failures were quite intense in some cases. We can see here a lateral displacement of about 20 centimeters and a ball-shaped settlement of the backfill of the quay wall. However, one should take into account in these two cases the poor quality of both the materials and the construction practice at the time that was constructed. Now, for the Chios port, for the Chios island, the port is located very close to the Ecemis city of Turkey, about 15 kilometers. The main finding in this case was an extensive zone with surface cracks parallel to the shoreline. It was surveyed a few hours after the earthquake by Professor Pelekis. And these extensive cracks had a width of about 5 to 10 centimeters, while their depth was about 40 centimeters, a quite considerable value. Again, in this case, liquefaction should not be excluded as a possible earthquake-induced phenomenon, because there was also evidence of lateral spreading effects. However, also gravity-induced failures were reported by local engineers that should be accounted during the interpretation of the observed behavior. Now, there were also records of rock slides and of landslides and rock falls, about 6 cases. Most of them were imprinted in Samos Island, but they were not spectacular. Therefore, I will save time and I will pass directly to the conclusions for the part of the quay wall's performance. The main findings can be summarized that the ports in the northern part of Samos, like in Vathi, Karlovy, and Kokari, were significantly affected, as opposed to the southern part, where the damages were less intense. The earthquake effects on the quay walls were mainly manifested as displacement and rotation of the quay walls towards the water, plus pavement cracks and settlements of the backfill. The maximum wall rotations were recorded in Vathi, and it were in the order of 4 to 5 degrees, leading to displacements towards the sea of about 35 centimeters, while maximum backfill settlements were also recorded in Vathi in the range of about 50 centimeters. Traces of ejecta indicating possible liquefaction of the backfill material were recorded also, mainly Vathi, Karlovy, but also in the town of Chios. However, it is still unclear if there was liquefaction in the subsoil under the quay walls. As a final comment, research is needed, of course, to simulate the observed behavior and explain the recorded damages. And now, with the permission of the moderators, I would like to give the floor to Professor Pelekis to continue with the liquefaction observation and the associated lateral displacement effects.
So, in this section of the presentation, soil liquefaction and lateral spreading findings will be discussed. I will focus on in three sites. First, Rovithis, which is located not close, at town of Karlovasi. Mylonakis site, close to Vathi town, the capital town, and also to the coastal area of Vathi, which is beyond Aegean Port. Let's start first with Mylonakis. Ground cracks compatible with lateral spreading mode of failure were observed. Ejecta and sand boils also observed as well. During the second phase of Reconnaissance, this profiling and soil sampling were conducted utilizing MSW method and excavation of two trial pits. As you can see from the VS data, up to the depth of 5 meters, the shear wave velocity remains below the value of 200 meters per second. And the trial pitch reveals the liquefiable material consists basically mainly of silty sands up to sandy gravels with some mixture of organics and with organics. And the grain size analysis indicates that the gray material, which is underlaid by field debris surficial layer, which is lies underlying in the area of high possibility of liquefaction with D50 parameters, as you can see in fine to coarse, fine to medium sand. What else? The materials found to be non-plastic, and the fine content was varying between 10 and 20%. Let's continue to the second site, Rovithis. At Rovithis site, structural damages at least 3 locations were compatible with lateral spreading failure mechanism. Also, numerous ground cracks were observed in combination with a mild sloping ground, indicating lateral spreading failures. You can see here we had cracks along the main road, the coastal road, and many cracks. This is just indicative. These cracks are just indicative. We have had many cracks parallel to the shoreline at all the area. By measuring the crack openings along the green arrow, we estimated a value of approximately 5 centimeters cumulative horizontal displacement along a line of 44 meters. We performed also MSW measurements, and again the results revealed soil formations with VS values less than 200 meters per second, up to 5 meters from ground surface. It should be noted here that a very small amount of ejecta observed, especially at these two roads here. The next site is the Vathi, is a seafront or coastal area. This case study, as I said before, is beyond Aegean Port. A major part of the seafront suffered from ground cracks openings parallel to the seafront, indicating lateral spreading effect. No ejecta observed whatsoever. The cumulative horizontal displacement along these two green lines found 12 centimeters approximately and 8 centimeters along a lines of 48 meters and 27 meters respectively. The VS profile obtained from MSW indicate the presence of soft soil formations up to 10 meter depth from ground surface, having again values less than 200 meters per second. As stated in previous slides, ground cracks parallel to the seafront observed in the port of Chios Island, indicating marginal lateral spreading or liquefaction actions. Preliminary assessment of the safety factor against liquefaction carried out based on VS profile and recording at Cetin. I will remind you that the PGAs at Cetin town was 0.15 G in the east-west direction, 0.12 G at north-south direction, and 0.08 G at Z direction. The results of the analysis indicates that for a magnitude of 7, the required PGA for triggering liquefaction is 0.12 G. And for the analysis, we assume that fine content percent of 5%. As you can see here from the first graph, the VS profile indicates values of VS starting from 100 meters per second up to 200 meters per second in the first 10 meters of the site. The findings, the major findings. Manifestation of liquefaction and lateral spreading were observed in the north coast of Samos Island, especially Rovithis and Karlova Sea town. The associated phenomena were not spectacular, which suggest marginal liquefaction. This is remarkable given the density, PGA greater than 0.2 G, and the duration greater than 10 seconds on the ground motion. Potential liquefaction was also observed in the port of Chios Island, which is located 80 kilometers from Fort approximately. A number of large lines and rockfalls occurred in the north part of Samos also. Again, the relevant phenomena were not particularly severe and probably relate to precariously standing rocks and slopes. Research is needed to quantify the above observations and incorporate the relevant data into the global liquefaction databases. Thank you very much for listening. Of course, we want to address many thanks to many people that help in our effort. And I'm ready for your question, if there are any.
Thanks, Takis, for and Manos for the interesting presentation. I think we have exceeded here the available time. There is a comment regarding the ports, probably from George Boukouvalas, if I'm not wrong, because I can only see initials, who mentioned that soil liquefaction is not necessarily, it's not necessary for observing this type of behavior in the key walls. The very inertia of those massive structures in combination, of course, in conjunction with a unilateral movement due to the presence of backfill might be sufficient for developing those type of response. But I don't want to consume more time. I would like to yield the floor to Kemal to continue with geotechnical observations on the Anatolian side, and maybe at the end we may have time for more Q&As. Kemal, the floor is yours.
George, thank you so much. We will present our geotechnical reconnaissance findings in 15 minutes, and I believe we can do it. We'll follow the similar approach I assume everybody can see our presentation at the moment. Again, we have a long list of contributors, and that makes this work valuable because we believe in collaboration. In this part, in addition to the site effect-related geotechnical issues, which we discussed earlier, we will talk about performance of building foundations, seismic soil liquefaction manifestations, and in these ground failures. Then seismic performance of slopes and deep excavations and retaining structures and key walls. Let's start with Professor Altun and Professor Sezer to basically get their expressions and observations regarding the performance, especially foundation performance of residential buildings. Professor Altun, Professor Sezer.
Thank you.
Thank you very much.
Professor Cetin. During and after the earthquake, many buildings damaged or totally collapsed. Performing the reconnaissance study, it was tried to investigate the relationship between damage and soil conditions. So it was known that soil conditions are very weak, especially in Bayraklı region. It is wondered if the damages are caused by insufficient bearing capacity or weak soil structure interaction, base damage or settlement occurred. And Professor Sezer built some findings dealing with foundation performance in Izmir province or surrounding cities, depending on our observations. Word of you.
Thank you very much, Professor Cetin and Professor Altun. Let me summarize the situation. Let's talk about what is to be said finally. After 2020 October 30 earthquake, several issues related with foundation performance were reported. However, damage and collapse of buildings were mostly due to problematic concrete works, reinforcement detailing, and structural performance. However, this was a relatively far-field motion, and there are many fault systems in the vicinity and inside Izmir city center, and the influence of the near-field ground shaking should well be analyzed. As you can imagine from the forthcoming slides, there is a clear site effect in Manavkuyu district, namely the Bornova plain, and the buildings were collapsed on a relatively far site. These damage images, can we please roll back? Professor Cetin, thank you very much. These damages are from a relatively close city, a city which is close to epicenter of earthquake, the Özdere city. Could you please go on? Thank you very much. So these images are from Söke city, my hometown. This is the foundation system of the old building did not perform well, causing formation of cracks in superstructure. Could you please next slide, jump to next slide. Okay, so coming back to here, settlement and tilting of superstructure was also observed after ground shaking in Kuşadası city, which is located 40 kilometers to earthquake epicenter, which is a relatively close city center. Next slide, please. Now we're coming to northern Izmir, 80 kilometers north of epicenter of earthquake. We can emphasize that the foundation systems performed relatively well. Problems were mostly related with amplification and structural issues. Next slide, please. Okay, Manavkuyu district, it is 75 kilometers far away from the epicenter. Damage in Izmir is due to the basin effects and amplifications. Damages due to structural problems can also be reported, and these damages will be detailed in sections 6 and 7. Since the maximum ground acceleration was relatively low, a surface manifestation of liquefaction was not observed in Manavkuyu center due to our reconnaissance field service. Okay, next slide, please. Can we roll back, please? One more. One more. Okay, thank you very much. A tsunami hit Selçuk, which is 40 kilometers far away from the earthquake. Performance of the foundation systems were reasonable, and low-rise buildings dominating the city was an advantage here. Next slide, please. Coming back to Manavkuyu, 17 buildings were totally collapsed after 2020 earthquake. A clear side effect and the effects of local soil conditions were observed here. Underlain by a thick alluvial layer, soils underlying this zone provided high amplification and double basin effects. These effects caused structural problems, particularly in ground floors. It should be noted that the differential settlement in buildings or structural problems due to foundation type was rarely encountered. Next slide, please. Okay, similar things can be pronounced in these photos from Manavkuyu district. High amplification, double resonance effects. These were coupled with very low superstructural performance. Next slide, please. Okay, again in Manavkuyu district, structural problems observed particularly in ground floors. Damages were mostly based on structural issues. Damage due to low performance of the foundations was rarely encountered. Next slide, please. The first two photos here, this one and this one, are from Konak district in Izmir city center. These old buildings and ground shaking caused problems in these masonry structures, which are located above relatively stronger profiles. Later, two images are from Karşıyaka district. The performance of this building in Karşıyaka district is very low. And photos from ground floor of this U-shaped building in plan, it is hard to pronounce foundation problems. However, amplification effects are considered to be effective, as in Manavkuyu district or in Bornova plain. Next slide, please. Thank you. These photos are again from northern Izmir, Karşıyaka. First two images show poor performance of superstructure under ground shaking, and the last two belong to a building located on a poorly engineered field, which the tilt was augmented by ground shaking and high amplification. Thank you very much, Professor Cetin and Altun. The floor is yours.
Thank you, Professor Sezer. Definitely, these structural related issues will be discussed in a detailed manner when we're having session number 7, but you have very clearly addressed that basically the problems were not associated to the foundation elements or bearing capacity or liquefaction type of problems, but more of a structural detailing related issues and increased seismic demand due to side effects. Having said that, let's take a look at the situation from soil liquefaction point of view. Professor Unutmaz, Professor Ecemis, and Ms. Ilgaç and John will help us with that.
Thank you, Professor. I want just to begin. We have visited the site after the earthquake, and you can see the points located on the map on the right that we have visited. The map on the left shows you is proposed by USGS, and it shows the liquefaction prone zones of the area. However, we have visited most of the sites that are shown on that map, and we have pinned them on the map, as you can see, and the letters LN means there is no liquefaction on those sites. We have gone south down to Kuşadası, Davutlar, and up to Çeşme, and in that area, and we have seen especially, I want to say no sign of liquefaction, but there's a little, in the pictures on the right, you can see the coasts of Gümüldür, Çeşme, Kuşadası, and as you see, there are no signs of liquefaction, no signs of lateral spreading or superficial cracks, anything on the contrary to the findings of the Samos Island site. But we have seen a liquefaction case in the upper parts of the area in Gülbahçe, and I think Nurhan can give you some more details about this site. Thank you.
Thank you so much, Professor Unutmaz. Actually, we engineers sometimes get demoralized when we see lack of failures because we are more attracted to failures. But we should remember that sometimes lack of failure should also be documented, which brings a lot of good information to engineering practice. So Professor Berna Unutmaz discussed the lack of liquefaction. Now I would like to kindly ask Professor Ecemis to discuss, I think, one liquefaction case from Gülbahçe. Professor Ecemis?
Yeah, thank you. Thank you, Professor Cetin and Professor Unutmaz. So I will give a little bit information about the Gülbahçe. Why it is important? Because we observed little bit sand boils and liquefaction manifestations in the sides of the Izmir. So from our previous knowledge of soil characteristics, we know that fine sands and silty sand is much more observed in these sites, so especially in Urla and Bayrakli, which are susceptible to liquefaction. But we didn't observe any damage or no liquefaction manifestations at these sites, except one place in Gülbahçe, İçmeler. We observed sand boils here during our surveys, and these sand boils may be due to the eject of the hot water, because at this part of the city, we also observe hot waters coming out from the ground. So this may be the reason to see the sand boils. So we cannot say all perfection, but we have to do more research about this because hot water is going out there. So this may be the reason for it. So I think it is important to consider the effect of system response of liquefaction deposits, because in New Zealand earthquake in the period between 2010 to 2011, they also show that the system response of liquefaction is an important factor for manifestation of liquefaction. So system response, I think, needs to be considered in these cases.
Professor Ecemis, also, would you say a few words about Manavkuyu? Because no surface manifestation in Manavkuyu, but there is, however. I would like to hear the however part.
Okay, so no surface manifestations also observed in Manavkuyu, but however, we saw this as edge source here, structural and foundation, so the damage from here. So I think there is a surface manifestation at this part of the city we observed, but as I said, we have to do much more research about these things to observe.
Excellent. So maybe the surface manifestation is hidden, and we will do some detective work to find out the evidence for liquefaction. Thank you so much, Professor Ecemis. Also,
sorry,
please.
May I interrupt you?
Please, please.
These are gravel columns or stone columns under an old building. Water came out of these columns during earthquake ground shaking, after the earthquake.
So they worked as a drain during the earthquake and released some of the pore pressure generated.
Exactly,
that was a very interesting comment. Thank you so much.
Thank you very much, Professor.
Let me move on with the next slide. Professor, maybe God is making me to say that because Makbule and Gizem is about to become PhDs very soon, so I should call Miss Ilgaç and Miss Gizem. Would you please share your preliminary SPT-based liquefaction triggering assessments from İzmit Bay, thanks to courtesy of Professor Altun and Professor Sezer, that they share the data? Yes, Makbule.
Sure, Hocam. We have attained the data, the SPT borehole information from Izmir area from our colleagues in Izmir, and we have started immediately processing this data in perspective of liquefaction triggering. And here you see the Cetin Atoll 2018 boundaries and liquefied and non-liquefied regions. And the red dots represents the case histories that we have recently processed, non-liquefied sites from Samos after Samos Aegean Sea earthquake. They have relatively lower SPT below counts, smaller than 20, and they have fallen in the non-liquefied region.
Thank you so much. I know to be able to prepare this plot, you didn't sleep last night. I am well aware of it. Thank you so much, Makbule. Gizem, this is the CPT world, I assume. Would you say a few things about the CPT domain?
Yes, Professor Cetin. Thanks to Dr. Altun, we have the CPT all around the Izmir Bay area, and we try to look at them. We mimic their critical layers and then characterize it. Then this is not the final, but the preliminary assessments for the CSR tip resistance plot. And on this figure, we have also Moseto 2006 as a boundary, but still it needs a little bit more discussion, I think, for the cases.
It looks like both of the cases from this event complies well with existing liquefaction triggering relationships. Thank you so much, Gizem. I know also you didn't sleep last night, so that was well appreciated. Let's talk about slopes and deep excavations. Mr. Soylemez, would you please tell us the reconnaissance findings about deep excavations and slopes quickly?
Yes, Professor Cetin. Considering the performance of deep excavation systems, no failures were observed or reported due to earthquake, and actually this can be supported with the measurements taken by 2 inclinometers. Also, as you can see in the next slide, we also didn't see any slope instability problems. Only a limited number of rock falls were observed, but besides that, all the slopes were safe and sound.
Thank you very much. So from slope performance and deep excavation performance points of view, from the Anatolian side, we didn't have significant failures of engineered structures or even non-engineered structures. So let's say a few words about retaining structures and key walls. Ms. Çakır, would you please share your experience with the retaining structures?
Sure, Professor. As this slide shows, there were some partial collapse and tilting in safety walls. However, as in the next slide, there were no damage observed in the engineered retaining walls. And as in the last figures, these are the spillway pictures from the dams around that area. And these, there are no, again, structural failures in these walls also.
So interestingly, from geotechnical engineering point of view, from the Anatolian side, we don't have very many liquefaction cases. Only a localized area, as very well said, basically Gülbahçe, where the artesian pressure is dominating the region. So maybe that liquefaction triggering was also contributed by artesian pressure, retaining structure, building foundations, natural slopes, key walls, deep excavations performed really well, except structural damage located or concentrated in Bayraklı. So that was the summary or concluding remarks of the geotechnical reconnaissance findings from Anatolia. To add a personal aspect, because it looks like we pretty much used the time very well, this is Elif Perinçek's picture. She stayed longer than 60 hours under the rubbles, and then she was saved. A 3-year-old cutie holding the tongue of her saver, which made everybody cry. We prayed for her and she recovered. So maybe that is a lesson that we should keep in mind when we're dealing with this kind of problems. Thank you, Professor Mylonakis. This is the end of geotechnical engineering session. From
Thank you. One comment. I tried to respond to save time because we are beyond the limit. I tried to respond directly to some comments. One was actually referring to the previous chapter, maybe also to this one, as to the lack of observations of liquefaction in Bayraklı. And we know the answer as co-authors of the chapter, but please make a quick final comment, although I responded directly in writing.
Professor Mylonakis, a very quick response. PGA is very low. PGA in Bayraklı is about 0.12 G. Relatively speaking, it is nothing. On rock sites, 0.8 Gs, 0.7 Gs. It is nothing. The problem with Bayraklı is spectral acceleration at the period range of the structures is very high. So liquefaction, foundation performances, slope performances, and other retaining structure performances, they're governed by PGA. And PGA from this event in Izmir is relatively low.